All right, we're recording. We're live. Here we go. All right. So this is the topic of systems of equations. And you guys, I think, actually know a thing or two about it if you took Algebra 1. Of equations. Okay, Algebra 2 textbooks, Chapter 2 if you have one, or you want to look at one. I have a bunch in my classroom if you ever wanted to look into it. Anyway, so a system of equations, what does it look like? So what I'm talking about specifically, a system means there's multiple things in it. It's a system means can have 2 equations or 3, but it has to be at least 2. So y equals 3x plus 1, and y equals negative 1/3 x. No y-intercept there. Okay? And now, that is a system. Okay, so if you're asked what a system is, you can now kind of at least show visually what a system is. Okay? Alright, so what type of questions would you see on SATs or on this topic? They would tell you to solve the system. So you would have like an example like this, and it would say, solve the system, or find the solution to the system. Solve it, find the solution to it, solve, find solution to. Alright. Alright, so that's our goal for today's lesson. Can we find the solution to a system? Alright, by the way, look at the system for a second. Can we tell what type of relationship the 2 equations within the system have? Yeah, Vasilisa.
They're perpendicular.
They are perpendicular equations, okay? They don't have to be, I just chose them to be. Okay, so your system doesn't have to have perpendicular. Your system might have parallel lines, by the way, and if your system has parallel lines, well, you're about to find out in a second, that's going to be no solution. Alright, so what does it mean to be a solution to a system? Simply put, I can define it as, alright, I'm going to put a little definition here, let's put it in blue. Alright, the definition of a system, alright, of that, or a definition actually is not to a system of equations, definition of a solution to a system of equations. So it's a definition of a solution to a system of equations is, simply put, where the lines cross. I actually defined it differently in the last time I taught it, but that's just I'm using a very simplistic version of the definition in the format x comma y. Okay, so it's an ordered pair, a location where the 2 equations in the system, where they intersect. Okay? So that's the goal here. We want to find a solution to the system, the solution being in the format of x comma y, where the lines cross. Alright, so what's one way that you guys can think of to find the solution for that system right there? What's one way you guys can think of to find where the lines might cross? No one has any thoughts? Where? Yeah, Dom?
By graphing both equations.
That's a fantastic idea. Let's just graph both equations and see where they cross. So Dom is thinking critically about this. He knows the solutions x comma y, where they cross. That's what I said right here. Let's just find out where they cross. Okay, so plus 1 and then 3x, so it's like, we have one line that looks like that, something like that. If I had graph paper, I could give you a more precise answer. But I might just ask you to give me something generic, like, oh, it's about here, and just circle where your solution is. All right, and the other one is negative 1/3 x, which looks something like that. So they are perpendicular. That's just this situation. And so they intersect somewhere here, and I'm going to call that point, let's go with negative 1 comma 1. Okay, it's somewhere near there. I think it's something fractional. But I'm going to go with negative 1 comma 1. So that would be the solution to that system based off graphing. Can we follow so far? All right. Is there a question about your test?
No, I got this. Can I use the bathroom to tell you? Because I was playing basketball.
Yeah, you do that. Thank you. That's on recording now, that question. You could have just walked out. That would have been preferable, but thank you. Okay.
Wait, how did you graph
Negative
negative 1/3?
1/3 x, so the y-intercept is what here?
0?
0. And then I go up 1 over 3. I do the negative 1/3 slope. Okay, good question. All right, but graphing, it's not always the most precise thing. Unless you have a graphing calculator, it will in fact tell you the exact answer. So it's to your benefit that you have a graphing calculator for this next upcoming topic. All right, and then you would just put y equals one equation, y equals the other, graph, see where they cross. It's actually going to tell you the point, where they cross perfectly. All right. So we now know one way to find a solution to a system, yes? What is the one way we just discussed? Graphing, awesome, we're paying attention. Alright, the other way is called substitution, okay? So there's actually two methods to solve it algebraically. One is called substitution, one is called elimination. So substitution to solve, okay, we're going to discuss that today. And the other one is elimination. Elimination. And that's also used to solve, but we're not talking about elimination today, and your homework will only be on substitution and graphing. Okay? All right.
You have one more?
Yes, of course. Okay. All right. So I'm going to focus on substitution. I'm going to erase all this on this side so we can start the process of substitution. I'm going to use that same system. Let's see if we can actually get the precise answer, not this vague kind of like visually, like that's what it looks like visually. Okay, so substitution, elimination. All right. All right, so substitution, as the name implies.
Wait, I didn't get that question.
You can watch the video later, buddy. Okay.
Wait, what is it? I'm sitting over there.
All right, substitution, as the name implies. This is now substitution. We're going to substitute the value of one variable, substitution. We're going to substitute the value of one variable for another. Luckily for us, both of these equations are solved for a single variable. Y equals Y equals. So I'm going to substitute this value here. We're going to take this Y, and we're going to substitute it what this Y is equal to. So we're going to substitute it with this. So that 3x plus 1 will go where that Y is, and that'll help us solve. Okay, so what will it look like? 3x plus 1 equals negative 1/3 x is a proper substitution for this problem. And now, we have an equation in a single variable, which means we can solve that equation for the value of that variable. We follow?
Wait, what did you just do?
I just took this y here, right? So I took this y, all right, which is equal to that y. The y equals this and y equals that. And I took this 3x plus 1, which is equal to y, but I plugged it in for this y instead, which you can do as a method to solve. That's totally legal. Okay? So I know I'm going to end up with a fraction here, but I'll just try to run through this process fairly quickly. I'm going to multiply by 3 first. Let's get rid of the fraction. So I have 9x. This is legal. This is one way to solve it. You can do it your own way. Plus 3 equals negative x. I'm going to, let's just take the 9x and subtract from both sides. Divide minus 9x minus 9x.
Where'd you get 9x?
I multiplied everything by 3 to get rid of this fraction.
Okay.
Right? I use the multiplication property of equality to get rid of my fraction for me. It's helpful. Right? You could have just like subtracted 3 from both sides, but then you have like negative 3 and a third x. I didn't want to mess with that, so I did it this way. So negative 10x equals 3, and divide by negative 10 on both sides. So x looks like it's equal to, unfortunately, 3 over 10, negative 3/10. Positive divided by a negative, that's a negative value there. Okay? What does that mean? That means the solution to the system resides somewhere at negative 3 over 10 comma something. It's a fractional location. So on the x-axis, I'm going to go negative 3/10 over. Does kind of look like it's negative 3/10 over. If you ask me over here, this point, it looks like it's negative 3/10 over to the left. What's the y value though? So that's half my answer. This is half my solution done using substitution. I'm halfway through the process. How do you think I should complete the process? Done.
By plugging negative 3/10 into one of the x's.
That's a fantastic. So I actually have to pick one of these two equations, okay, to plug my negative 3/10 into. I'm thinking probably this one looks a little bit easier to me. So I'll go y equals negative 1/3. I'm going to copy it down, but instead of my x, I'm going to put the x value of my solution. Negative 3 over 10. All right, guys, what does this make? Somebody tell me. I can't look at fractions anymore.
1 over 10.
1 over 10, yeah, thank you. Y equals 1 over 10. So 1 over 10 over here. And this is the location of the solution of this system of equations. Okay? Did we follow that? All right. I'm going to give you one more prompt to try. on your own. Maybe I'll pause the video and come back to it after, so that way it's quicker on video. One more system, okay? So I'm gonna write the equations first so you guys can get started working. All right, and if you're watching this video, then you should be trying this as well. X plus 2y equals 4, and x equals 3y
This is a new problem.
plus 15. I hope these lines aren't parallel or something. I hope I didn't mess with it. Here's another system of equations, okay? Your job is to find the solution using substitution. Yes, we can graph it. You can change it to y equals mx plus b. You'll get a chance to practice that for homework. I just want you to practice substitution. You're probably not so familiar with substitution, so. What do you think? Can you find what you want to substitute in for what?
So that's a b and y equals mx plus b form?
It doesn't. You could actually, the format it's in right now lends itself very well to substitution because we already have an equation solved for one of the variables right here. So what are you going to do? You're going to take this, probably, right, and plug that in for x over here. That makes sense to me. You guys follow?
Yeah.
All right, I'm going to give you a chance to work, and I'm going to pause the video for a second. I will continue it. See? Lunch today? I
What'd
can't
you
tell you.
eat?
Me and Mr. Spencer went out to Dig. You guys ever tried Dig before? The Dig restaurant
Oh,
Dig in?
there is some.
They are good. But I'm so full right now, and I'm getting like the itis, you know what I'm saying?
Did you use
Wait,
your
what'd you
lemons
get?
today?
I got like double protein, like chicken and pork loin, and some like rice and carrots and like Brussels sprouts. Like I was like, it was very good, yeah.
Mr. Fink,
But I all of a sudden just got very tired. What's up?
were you joking about the lemons? You were being so serious.
No, that thing was serious. Yeah, I was dead serious about that.
Oh.
But I didn't use. I still smell fresh from like yeah.
What do you mean you didn't use it?
I didn't use this morning,
What
but it still
about
smelled
It's
good.
a panic.
Is
It's
it
still
like
recording.
Huh?
It's a panic. It's still
Cold.
recording.
Cool?
Yeah, it's like lemon slices. It's
Oh
like
yeah,
lemon
it is. It's still
No, it's not. Don't. Okay. Wait, is it? Yo, how did? Who pressed record on it? Who pressed record on this?
Are we still doing the substitution?
Yeah, substitution. Okay, so substitution here. So did you guys catch what I was saying before? That this gets plugged in for the x. So can somebody give me the equation they wrote for this, Amelia?
3y plus 15 plus 2y equals 4.
Plus 15 plus 2y equals 4. Yep, that's perfect. Okay. All right, so again, we have an equation in a single variable. You guys can solve for the value of that variable. Yeah, do you guys know
Wait,
do you guys remember the rest of the
We
process?
took out the x's.
Yeah, so there's no x's now.
Okay.
So you're gonna end up with y equals something. And then we're gonna take whatever that y value is. If one of you get it, let me know. You got it, man?
Is it 9 over 5?
Lexi, what you got?
Negative 11.
I got negative 11 over 5.
Alright, I'm gonna do it. Let's
Oh
just
wait,
do
I
this
just did
quick.
my math wrong. It's
2.2.
negative 11.
5y plus 15 equals 4.
It's negative 2.2.
5y equals negative 11. Y equals negative 11 over, another fraction. Okay, well, we have half my solution now, right? Negative 11 over 5. Okay,
Wait. You add both the y's?
I combine like terms, yeah, on that left side of the equation, I combine like terms. You know, editing takes a while, right?
Wait, I just asked a question.
No, but whoever unpause it takes a second to edit that. Actually, it doesn't take too long. Just YouTube, I think, has a function where I can do that. All right. So, what about my x? Did anyone solve for my x yet?
21.6.
21 point. Can you give it to me in fraction form? Why 21.6?
As I'm using a calculator.
Oh, okay.
Okay.
Okay. Well, let's see. Which one looks easier to plug it into? I think I'm gonna do this one. All right. So, x equals 3 times the quantity of negative 11 over 5. I'll try to pick cleaner equations for you, so it ends up being integers here. But it's good to practice with
Oh,
fractions.
maybe I did it wrong.
What'd you say? You did it wrong.
Yeah.
Plus 15.
Ouch.
All right, so that's going to be x equals negative 33 over 5. Plus, and I'm going to convert that to being over 5. That's 75 over 5, by the way. Okay. And then so when I add those together, I get 72, 42 over 5.
42 over 5, yeah.
X equals 42 over 5. Dang, that's nasty. Okay. I've seen worse fractions. Okay.
Wait,
So that's your solution to that system using substitution where the equations are organized slightly differently. Okay? That's my lesson. Hold on.